you learned the other day that z raised to the n power is equal to r to the nth times the cosine of theta times n plus I sine of theta times n. But today the question is, what about z to the 1 over n power? Oh, I'm sorry. Take out a scratch sheet of paper. I didn't leave space for this in your notes. Or you can simply look at the notes that you have on your back page. I have that included right on your back notes. So like I have a formula sheet, you're going to find it on your formula sheet. So either write it down or look for it on this formula sheet. Good. Yep, Allie's got it right here. Okay. And she sees nth roots right here. The one that says nth roots, that's where you are. Everybody got that? Okay, so z to the 1 over n. Anybody want to guess what I do to r?
1 over n.
Good. And then it changes a little bit. It's cosine of theta plus 2 pi k divided by n plus I sine of theta plus 2 pi k divided by n. Now, it turns out that if it's the cubed root, there's 3 solutions. If it's the 4th root, there's 4 solutions. If it's the square root, there are 2 solutions. If it's the 5th root, there are 5. So this represents the number of solutions. We have w sub 0, w sub 1, w sub 2, w sub k, all the way down to w sub k, okay? Where k is equal to 0, 1, 2, 3, all the way up to your n minus 1. So I'll explain what this means. Suppose that we are going to find the 4th root of something. There are how many solutions? 4. We start with w sub 0, then w sub 1, w sub 2, w sub 3. We stop with n minus 1. There are 4 solutions. Because we're counting 0 as 1, see how we get 4 there? So that's all you have to think about, okay? We good? All right, we're ready to roll. Go to your notes. And that was de Moivre's theorem. Sorry, I'm all over the place right now. Busy day today. Square roots of negative 81i. Square roots of negative 81i. I'm first going to identify n, and I'm going to identify k. What is n in this problem? Close? 2. N is 2. N is the number of roots that you're going to find, because there's a square root, there's 2 roots. You see that? So my k values are going to be everything before 2, so 0 and 1. Good? Now I need to take it and place it in a trigonometric form, where we find r and theta. You want to do it the easy way or the difficult way? Okay, so I'm going to graph this 0 minus 81i. I go over 0 units on the real axis, and I go down 81 units on the imaginary axis. So the r value is the distance from this point to the origin, which is what? 81 units. Everybody okay with that? And then theta is this angle. 270 or 3 pi over 2. Good? Okay. All right, sweet. So I've got my trigonometric form, which is 81 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2. Everybody in a safe spot? Feel like we're not super confused yet? Good. I mean, but if you pause, like we've already done a decent amount of work, haven't we? That's what makes this tough. There's so many moving parts to it, okay? So we've got that, okay? So now let's venture along. We're going to do W sub 0 and W sub 1. Those are going to be my solutions, W sub 0 and W sub 1. So W sub 0 is equal to, and the formula says you take the radius, which is 81, and you raise it to what power? The 1/2 power. And then you multiply it by the cosine of theta, which is 3 pi over 2. Then you add that to 2 pi times k. What is your current k value?
0.
K is currently 0. And 2 pi times 0 will be 0. And we divide that by n. What is n? 2. Plus I sine of, and now let's simplify this. What is 3 pi over 2 divided by 2?
3 pi.
Over, I'll do it once. Hopefully we can see it, but then hopefully we don't have to do it again. 3 pi over 2 divided by 2. Multiply by 1/2. I get 3 pi over 4. Yep. Good. W sub 0 is equal to, what is 81 to the 1/2 power? 9. So it's interesting, as you look right off the bat, it turns out the square roots of negative 81i, I mean, just think about it. If I said the square root of 81, you would say 9. If I said the square root of negative 81, you would say 9i, right? So this is 9, this is 9i. We're asking what's the square root of negative 81i. Well, that's a little bit more challenging, isn't it? Yeah, so we're trying to figure that out. And it turns out it's going to be whatever we come up with here. No surprise, it does have a 9 in it, but what comes after that? Turns out you get the cosine of 3 pi over 4 plus I sine of 3 pi over 4. And that is what we call trig form. What else would I like to have? Complex form. Very good, Allie. So I've got 9 times, and now we're going to need the exact values for cosine and sine of 3 pi over 4. 3 pi over 4 is how many degrees? 135. So what is our terminal point? Negative root 2 over 2 plus I roots of 2 over 2. Good for that? That's complex form.
Alright, so like if we got this far, how many points did we get for the question?
So right now you'd have 4 out of 6. Okay, because we still got to find W sub 1. You see, it's not impossible, is it? But there's a lot of steps, isn't there? I mean, just think about, we used to do a whole assignment just on finding the terminal points of this. Do you remember that? That was like, oh, we're going to find the terminal points. We were sitting there, we were taking like 3 minutes to find some of these. It's like right now, like you want to know them, right? I mean, it's impressive how much you've learned over the year. You are smart. We've been smart. We've developed intelligence, okay? But if you want to get the last points, you got to be able to find W sub 1. And so W sub 1 is going to be, and it turns out the radius is going to stay the same, be 81 to the 1/2, which is just 9, times the cosine of, but now this whole 2 pi k changes things, because k is no longer 0, k is, so we have 3 pi over 2 plus 2 pi, because k is 1. Everybody see how I got the 2 pi? Good. So divided by 2, because it's square roots, plus I sine of, okay? And Trinity says, well, 3 pi over 2 plus 2 pi, instead of 2 pi, we're going to use 4 pi over 2. Does that make sense? So 4 pi over 2 and 3 pi over 2 make 7 pi over 2. And 7 pi over 2 divided by 2? 7 pi over 4. Yep, when you divide, it just changes the denominator. 7 pi over 4. Good. Glad you guys saw that. So that's the same as 9 times the cosine of 7 pi over 4 plus I sine of 7 pi over 4. And that is what you call trig form for your second answer. But we'd also like to have complex form. And it's not too difficult. Once you've done it once, we'll just do it again. And obviously, you guys can see now that this course builds on itself. So if your foundations of trigonometry weren't very good, then it's going to be tough to figure things out now. 7 pi over 4 is how many degrees? 315. So it's right there. So what's that terminal point? Root of 2 over 2 minus I root of 2 over 2. So it turns out it's exactly the same as the other one. It's just different by a factor of -1. Which should make sense if some of you are thinking about if you were to square it, the negative would cancel out. But it turns out, just so you understand what the heck you just did, if you were to take this and multiply it by itself, you would come out with exactly -81i. That some of this stuff in here just ends up canceling out. And if you took this multiplied by itself, you would come up with exactly, again, -81i. That's what you found out. Game today? What's different about this problem? Third roots. So this one will take a little bit longer. The next one's fourth roots. We're not going to do 4. For this last one, we'll just do the first one. That's it. Okay? Just show you how to set it up. But for the third roots, we say n is equal to 3 and k is equal to 0, 1, and 2. Any confusion about how I come up with that? I'm going to graph the -27i, and again, it's 0 minus 27i, so it's 27 units down on the imaginary axis. So theta is 3 pi over 2 again, thank you. What is the r value? 27, yep. So the complex form, which we did a couple days ago, that seemed difficult time. Now it's like, okay, that's just 27 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2. All right, let's roll. W sub 0 is 27 to the 1/3. See it? Times the cosine of my angle, which is 3 pi over 2, plus what? Plus 2 pi times 0, which is 0, divided by 3. Plus I sine of 3 pi over 2 plus 0 is 3 pi over 2. Divide that by 3 and you get 3 pi over, which is the same as pi over 2. (27 to the 1/3), 3 times the cosine of pi over 2 plus I sine of pi over 2. That is trig form. And hopefully some of you are like, oh, I really like the fact that we've come up with the pi over 2. Like, that's a good thing. I need to come up with the exact values for sine of pi over 2 and cosine of pi over 2. Pi over 2 is 90 degrees. What's the x value of 90 degrees? 0. So you get 3 times 0 plus I, which is just 3i. Now, that shouldn't be that amazing, because if you think about it, watch. What is 3i times 3i? -9, right? Because I times I is -1. Then if you multiply that by 3i, we get -27i. So we probably could have thought that through and come up with the 3i, right? But how many solutions are there? There's 3. Coming up with the other 2, well, that just blows our brain. But we've got this nice formula. Unfortunately, we are really good at trigonometry. So where do I start here? W sub 1 is equal to? 3 will stay the same, times the cosine of 3 pi over 2 plus 2 pi divided by 3. All right, so we got to calculate that. I think for some people that's kind of one of those difficult spots, okay? 3 pi over 2 plus 2 pi. 2 pi is the same as 4 pi over 2, right? 7 pi over 2. 7 pi over 2 divided by 3? 7 pi over 6. That's trig form. To find the complex form, I need the exact location of 7 pi over 6. How many degrees is 7 pi over 6? 210. Nice work. What is the terminal point at 210? Negative root of 3 over 2 and negative 1/2. So we have 3 times negative root of 3 over 2 minus 1/2 I. Doesn't matter. That's your complex form. So that's not as intuitive, is it? It turns out if you multiply this thing 3 times, you end up with negative 27i. That's harder to see, isn't it? That's definitely harder to see, okay? Now I'll do W. You know what? I've changed my mind here. So here's what I'm going to do for you for this, okay? So we're going to go to W sub 2. But you have a work day on Monday, okay? You got a work day on Monday, okay? And I already had that on the schedule because this is tough stuff. You got 3 days over the weekend, but obviously you're going to spend some time with family and whatnot. But because you got 3 days where you're not here asking me, I will post the answer keys for the last 2 assignments, but no others throughout the unit. Got that? The others will be up here, but for this complicated stuff, I'll post it because I know how it feels if you're doing something that's really, really difficult. You're like, I don't want to start if I feel like I'm making a mistake right away. Is that fair enough? Do you see my reasoning? What?
So, like, for the whole unit, you're not posting any of the answer keys? Like,
I'm keeping them right here.
Right, we have to look up here.
Yep.
Okay.
How about this? I would like to just write down the answers and post it up there. I'm a day late and dollar short. Like on a given day, I hope to get 81% of my stuff done. Like there's things that just don't get done. Just like the video yesterday. I mean, as soon as 7th hour comes in, I gotta run on the track and get stuff set up. Like it's just go, 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 go. So I was here at 6:45 this morning getting stuff ready. I mean, that's just the way life is right now. So, all right, okay, enough about me. No whining for me. I signed up for it, and I love it. W sub 2 is 3 times the cosine of 3 pi over 2, and now it's plus 2 pi k. What's my k value now? 2, so 2 pi times 2 is 4 pi. Good. So Trinity sees it. I got 3 pi over 2, and then 4 pi will be 8 pi over 2. That makes 11 pi over 2. Divided by 3 is 11 pi over 6. You know how helpful it is if you can do that computation, without having to write it out all the time? So 3 times the cosine of 11 pi over 6 plus I sine of 11 pi over 6. That is what you would call trig form. And now we move to complex form. And fortunately, we've got a good setup all ready to go right here. 11 pi over 6 is how many degrees? 330. So I'm looking at this location right there. What is that terminal point? Yeah, so it often works out that with these, once you find one angle, the other one's going to be very similar in terms of its terminal points. You can just see it's a positive root of 3 over 2. Minus I times 1/2 or 1/2 I, however you want to write it. And that's complex form. So like this problem on the test, this would be worth like right here, this would be worth like 8 points. Okay, the previous one would be worth like 6 points. I'm only going to be able to ask one of these on the test. You know what I mean? It would just take you so long. So I want to see, did you identify N and K correctly? I want to see, did you come up with this? You know what I mean? So that's like 2 points right there, okay? And then were you able to come up with one of the roots? Like if you use the formula correct, that's a point. If you come up with this right, that's another point. And then coming up with your last solution, that might be 2 more points, okay? So about 6 points, I think, is reasonable. But I don't think you should get half credit for just coming up with this. I think you got to be able to at least use the formula a little bit to come up with half credit. So, yeah. All right, last one. We're just going to do one, okay? Because this one turns out a little bit interesting. Not all of them work out as cleanly as that. And so just so you can understand the complexity, we are not doing the square root of I. Like you could, that's easy now. Like you guys could all just go home and do that. I mean, that's easy. We're doing the fourth root of -1 plus I roots of 3 over 3. That's what this is asking. I mean, like before today, you would have said that looks insanely impossible. Like not possible. You'd be like, there's no way you can take a fourth root of an I. And we're going to do it. We defy all logic. And it's easy. We just start with N. N is 4. Our W values are 0, 1, 2, and 3. We're just going to do W sub 0. So that's what I mean. But N still has to be 4. So when I say 1, it just means you're going to use that first one right there. Phoebe? Oh, I'm sorry. I'm sorry. Yep, you're right. Those are the K values. Thank you. Yep. No, you're absolutely right. Thank you. You're right. So we're gonna be doing W sub 0 to start. Yep. Okay. Before I do that, I have to put this in trig form, don't I? Now, that's not an easy one, is it? Like the other ones, we could just kind of look at them and say, oh, that's what trig form is. This was a little bit more difficult. So we've got R is equal to the square root of 1 plus we don't include the I. We square the root of 3 over 3. What do you get if you square the top? 3. Square the bottom, you get 9, so you get 1/3. What's 1 plus 1/3? Square root of 4/3. And we're going to leave it like that because it is no bueno. I mean, it's an ugly number. Okay, so we're just going to leave it like that. We're not going to worry about reducing it. So then I got to find theta, and I do tangent of theta is equal to yeah, so it'll be a negative root of 3 over 3. Where's tangent negative? Second and fourth. Why? Yeah, if you were to graph this, you'd be in the second quadrant, so we don't want that fourth one. I inverse the root of 3 over 3. .30 degree reference angle, which is how many degrees there? 150 degrees, which is what in terms of radians? 5 pi over 6. So it looks like I have the root of 4/3 times the cosine of 5 pi over 6 plus I sine of 5 pi over 6.
Oh.
Everybody okay with that? So we just put it in trig form. That was a little bit more involved than the previous one, though, wasn't it? Okay. So W sub 0 is equal to, I take my R value, which is the root of 4 over 3, and I'm going to raise that to what power? No. 1/4.
Oh, yeah.
Times the cosine of theta, which is 5 pi over 6, plus 2 pi k. What is k? 0, so that'll be just plus 0, right? Over 4. What is 5 pi over 6 divided by 4? 5 pi over 24. That's not a nice angle, is it? Like, we don't have a nice terminal point for that one, do we? So because we don't have a nice terminal point, we're going to have to use our calculator to just come up with a decimal. I'll show you what that looks like. So I'm just going to write this as the root of 4 over 3 times the cosine of 5 pi over 24 plus I sine of 5 pi over 24. And I'm going to say that that is, in fact, trig form. Whoop, sorry about that. I forgot this 1/4 power up there. Yep. So let's now multiply this, and we'll be done with this problem. Obviously, we'd have to do 1, 2, and 3 yet after this, but we're not going to. But I'm just going to go ahead and take that square root of 4/3. So square root of 4 divided by 3. Cool. Square root of 4 divided by 3, and I get 1.1547. And I'm going to raise that to the 1/4 power. So parentheses 1 over 4. So make sure if you raise it to a power like this, you include your parentheses so it does. Otherwise, it'll just take a little first power, and it'll take that answer divided by 4. You don't want to do that. And I get 1.036. So 1.036, I'm just going to write that down, times, and then we got multiplied by the cosine of 5 pi over 4. So I'm going to find out cosine of 5 pi divided by 24. And I get 0.793. Plus, and I would do sine of 5 pi over 24. And I get 0.609 I. And as you multiply them, 1.036 times 0.739, and you get 0.765, and then 1.036 times 0.609, and you get 0.631. So because it doesn't come out real pretty, we just write it like that. We just distribute. And so as we end, it means that if you take this and you multiply it together how many times? 4 times. You'd come up with -1 plus I root to 3 over 3. I dare you to try that. This is the beginning of what Leonard Euler did in his work to develop the most incredible equation in all mathematics. If you think of a good equation in mathematics, what do you think of? Give me an example of an equation in mathematics you know. Come on. A squared plus B squared is C squared. Good, that's a good one. Y equals MX plus B. X equals negative B plus or minus square root of B squared minus 40C over 2A, right? Got all sorts of equations. Leonard Euler takes the 5 numbers that are most important in all mathematics. If you said, what 5 numbers are most important in all math, what are they? What's the most important number in math, would you say?
1.
1? I love 1. That's a good one. Give me another one that's really important.
0.
0, super important. Think of another one that involves geometry. Pi. That one's pretty important, right? Think of one that involves logarithms.
Pi over 2.
Remember that number E?
Yeah.
That's pretty important too, isn't it? And then we also have this one. That's a pretty important number in the, I mean, really, as you think about all your number systems operations, those are pretty important, right?
Yes.
And it turns out that this equation is true. It incorporates all of them together. And it is this equation. That equation is true. And we can prove it to be true. I can prove it for you to be true. You just have to know a little bit of calculus too in order to do it. But wrap your brain around that for a second. Yeah, right? There's some mysterious things in mathematics that require ridiculous amounts of work and effort. But the beauty of it in something as simplistic as this really pulls together many of our number systems and our work all into one piece, which is pretty cool. So I'll try to get these answer keys online. If you're working this weekend and you don't see something posted, then you reach out to Mr. Gens, send me an email, and I'll get them posted, okay? But I'll be at track meet tonight, and you guys enjoy your weekend. It's going to be 70s next week.